Okay, we're going to take a look at addition of rational numbers. Because since we've already talked about addition of vectors, it's a very easy jump to go to addition of rational numbers. Okay. All right, by the key observation, the sum of x plus y for any two numbers, x and y, to be the endpoint of the vector x plus y. And that was, we've already proven that through our last lesson, so this is just a summary of what we've already done. So we're able to say that x plus y is going to be equal to the endpoint of vector x plus vector y. Or another way to write this is, you can show it as an association. If we concatenate x plus y and make that one vector, then it is the summation of vector x plus vector y. So what are some implications of this? Well, we know that 0 plus x and x plus 0 is still going to be x for any rational number, doesn't matter what. We can also say that the vector length of x plus the vector length of x star is 0, because the distance is the same for each one. They're just, one is a right pointing vector and the other is a left pointing vector. So when you take those vectors, they cancel each other out and you end up back at 0. We've also talked about the fact that addition of rational numbers both satisfies the associative law and the commutative law. So we know that. And we can also say that if x and y are both positive, then x plus y is equal to the usual addition of fractions, which we've already talked about. But if they are negative, then x plus y is negative and is the mirror reflection of the point x star plus y star. So again, going back to the concatenation, if you take the mirror image of x plus y, then it has a vector on the opposite side of 0 that corresponds with it. All right, so let's take a look at some computations. Let's go ahead and use s and t as our arbitrary positive rational numbers, and we're going to use s star and t star be our negative rational numbers. Well, if that's the case, then we have 4 possible combinations. We have s plus t, s star plus t star, s plus t star, and s star plus t. Well, we already know that s star plus t star is the same as taking s plus t and then taking the mirror reflection of it. And I'm going to ask you to verify this statement using a number line with these 2 rational numbers. So you're going to need to stop the video, and I want you to actually draw these out. Notice that you have the fraction ones. You're going to have to show partitioning, and then on your number line, and then show the vectors, how the vectors add up to this answer. When you're done, go ahead and restart the video. Okay, the other one is s plus t star. However, it is the same as s star plus t, because we can talk about any rational number. It doesn't matter that if one is positive or negative. Remember, we're talking about the mirror reflection, so it'd be s plus the mirror reflection of t, and that doesn't matter if it's positive or negative. So these 2 are the same, so we're just going to look at s plus t star, since it takes care of the other, what we come up with is going to take care of the other situation also. So if that's the case, we have 2 cases. If s plus t star, s can be greater than or equal to t, or s can be less than t. So what I'd like you to do is use a number line to show that 7 plus 3 star is equal to 4, but that's also the same as 7 minus 3. I want you to make that connection, and also do the same thing with 2 plus 5 star, which is going to equal a 3 star, but that is also the same as 5 minus 2, and then you take the mirror reflection of that. So stop the video and go ahead and show these on the two separate number lines, but show and explain how this happens. Okay, so you have those. So the consequences of this is that if you have s plus t star, and you're going to end up with s minus t if s is greater than or equal to t. And you can do that with any numbers. That's what your number line should have shown. Again, if you have s plus t star, you would end up doing t minus s and then taking the mirror reflection of that if s is less than t. So for these two for this situation where one is a number and the other number is the opposite, or the mirror reflection of it, then you have these two situations that happen. So you have to do some comparison. So in conclusion, what I'd like you to do is summarize all 4 situations that define adding rational numbers. So put all 4 of these together along with their consequences and their definitions. So we've kind of spread them out. I'd just like you to summarize them in one group so that we can talk about this as one set instead of broken out and with their explanations. All right, we'll do some more discussion in class and also tackle some practice problems.